You are in the meeting now.
Recording in progress.
All right. Good morning, ladies and gentlemen. How's everybody doing today? Thumbs up. I see one thumbs up. Hope y'all are doing well. Couple of thoughts. I'm about 67% done with grading exam one. Um, I can say that because that's when I grade in GradeScope, it tells me what percentage I've got completed. So I'm about 67% done. Hopefully, plan will be to have those completely graded by Wednesday's class. Um, Today is all about addressing your questions over assignment 8, functions and their graphs. Let's see. Let's take a look at the calendar real quick. Okay. It looks like I've reserved both Monday and Wednesday for this section. Um, Depending on how the day goes, we may proceed with assignment 9 on Wednesday, and depending on how that goes, we may even push assignment 10 up to Friday of this week. We'll just see. We'll just see how the day goes. We'll see how um, y'all are receiving assignment 8. So that's all I. Excuse me. That's all I got as far as announcements go. So at this point, I'm reserving the rest of the class to addressing any questions that you may have over assignment 8.
Can you do 4E?
What number was that again?
4E.
40? 40?
4E.
4E. Well, that
Yes,
does make
sir.
a difference. That makes a difference. 4E. The question uh, is y a function of x? So we have x squared plus y minus 1 quantity squared is equal to 4. Now, for y to be a function of x, there's a basic rule. The basic rule says that for each y, there can be, I see that's wrong there, D-H-E-R-E, can be only one x. For each y value, for each y that you plug in, there can be only one x. So, if you just take the time real quickly to solve for y, if you take the time real quickly to solve for y, what I would do is I would start off by getting this x squared to the other side. Now, what's keeping us from getting y by itself? Well, the exponent of 2 is. The exponent of 2 is keeping us from getting y by itself. So what happens if we just decide to square root both sides?
Hey,
Now,
Mr. Clopton.
anytime... I'm sorry, what?
Is it supposed to be positive 1?
4e? No. I have a y minus 1 quantity squared.
Ours say plus 1.
On 4e?
Yes, sir.
Well, it's not going to make a difference, but let me look. Alright, it really doesn't make a difference. It doesn't... Excuse me, it does not make a difference. So we can make this positive 1, it's still not going to make any difference. But what ends up happening, and we have to remember this, anytime that we square root both sides to get rid of an exponent of 2, we have to include the plus or minus notation. So we now have y plus 1 is equal to plus or minus the square root of 4 minus x squared. Now, fine, we'll go ahead and take it one more step. We'll put minus 1 plus or minus the square root of 4 minus x squared. And look what happens. If you plug in some value of y, or it doesn't even matter. If you plug in a value of x, let's plug in 0, because that makes it really easy. 4 minus 0 is 0. Or excuse me, 0 squared is 0. 4 minus 0 is 4. Square root of 4 is 2. And then you get that y is equal to, for x equal to 0, we get y is equal to negative 1 plus or minus 2. Which means that y is equal to what do we get? Negative 3 and a positive 1. So what ends up happening here is that for this value of y, you're getting multiple values of x out. And the key thing here is, and I made note of this in the notes, that if you ever have this plus or minus notation with your y, or in this case a y squared, anytime that you have a y squared or this plus or minus notation, we can then say that y is not a function of x. Y is not a function of x. So, shortcut for this problem. Anytime that you see an exponent of 2 attached to a y, or anytime you see y is equal to with this plus or minus notation, you know that y is not a function of x. Alright, what else can we look at? In fact, I want to show you something else real quickly. While I don't allow graphing calculators on exams or quizzes, it doesn't mean that we can't use a graphing calculator to get a sense of what's going on here. So, one of my favorite free graphing calculators is this graphing calculator called Desmos, D-E-S-M-O-S. Let's just type that equation in. X squared plus, open a set of parentheses, y plus 1, close parentheses, squared, equals 4. Oh, and look what this comes out to be. This comes out to be a circle. Now, what was one of the things that we talked about in assignment 8 notes? The vertical line test. And remember, on a graph, if you can draw any vertical line, and if it crosses the graph more than once, then the graph does not represent a function. Now, what's making this a circle, and we're going to talk about this later on, and not too far down the road, is that not only is x being squared, but y is also being squared. When you expand out this y plus 1, it's going to get squared. That's what's creating that's what's creating the circle. In fact, anytime that you have a y squared, I don't know, y squared equals 1. Let's make it a little bit different. Let's y squared equals x. A y squared function is just a sideways parabola. I apologize about my coughing. I picked up my son's cough and I probably gave it back to him. Vertical line crosses the graph more than twice, more than once, not a function. So, one thing that you could do for these problems in problem number 4 is you could graph these using, the point is not to be using a graphing calculator, but you could graph these to get a visual sense of why. What about the graph? What is it about the graph that's making this not a function? All right. What else can we look at?
Can you go over question 29?
29.
I don't know if it's hard, but it looks difficult. Oh, wait a second.
Okay. Just taking a second to look at where we're going to encounter this again. Anyways, this is called this function right here is called the difference quotient. And if any of y'all are going to go on into calculus, you're going to almost immediately see this difference quotient again. So we're not going to get into ins and outs of the implications within calculus. We're just going to follow the algebra here. So Just a real quick side example. If I told you that f of x was equal to 3, or better yet, yeah, so let's look up here. If I told you to evaluate f at 3 here, you would just say f at 3, or f of 3, is 2 times 3 minus 5, which would be 6 minus 5, which would give you 1. So what did you do? When I said to evaluate f at 3, you plug 3 in for the x in this function. Well, what we're told to do is we're told to evaluate this function by plugging in we're letting f of x be equal to 2x minus 5. So when we see this f at x plus h, this is telling us to plug in x plus h in for the x over here. So f at x plus h is equal to 2 times x plus h minus 5. Now that's just the f at x plus h. Let's see what this is. We're going to distribute the 2. So that's going to be 2x plus 2h minus 5. Now there's nothing else that we can do here because these are not like terms. 2x and 2h are not like terms, different variables. That is, excuse me, that is the f at x plus h. So what is f of x? It is just 2x minus 5. So let's pull everything together now. Remember, f of x plus h is the 2x plus 2h minus 5. We got that by plugging in the x plus h here for this x in 2x minus 5. So we have 2x plus 2h minus 5 minus now this minus sign means to subtract all of f of x. So I'm going to put all of f of x in parentheses. Now at this point we want to simplify. What can I start doing to simplify? Anybody? What can I start doing to simplify? Maybe distribute the negative sign? So we get 2x plus 2h minus 5 minus 2x plus 5 all over h. Now what happens? Anybody?
Combine like terms.
Yeah, and what are my like terms?
2x.
And
The 5s.
the plus and minus 2x, they cancel out. Any other like terms? I miswrote that. That should be a dot plus h, but a plus 5. What else are my like terms? Negative 5 and positive 5? Don't those cancel out? Now here's what we're left at. 2h over h. And what happens here?
The h's cancel out.
H's cancel out, and we're left with 2. And that's the difference quotient. So listen, schedule. Where else do we encounter this? I feel like we need to do another one. So let's do another one.
Can you do 25?
What problem?
25.
5?
25.
25. Okay, I'll do 25. I just want to do one more of these difference quotient problems. Now, we'll do 25. If y'all have more difference quotient problems, y'all can ask me. I would look up difference quotient. I can 95% guarantee you that a problem of finding a difference quotient will be given on the next exam. 95, let's just give it 100% guarantee. You will see this question again. So if you want to see another one worked out, I would love to work one out for you. 25. Find C at 2056 where C of x is equal to, we have a piecewise function. All right. A piecewise function is a function that's made of pieces of other functions. So if we just look in at this area right here, what we have is 3 functions. We have a linear function, 2x plus 3. We have a quadratic function, x plus 1 quantity squared, and we have a constant function. 3 functions, and what's happening here is they're being combined together, essentially to create a new and different function. Now, we can look at the graph of this here in just a second, but you only evaluate the part of a function when your x is in this given interval. So if I were to say find C at -3, I would want to know, where does -3 fit in any one of these intervals? Well, -3 is not greater than 3, so I don't use this part of the function. -3 is not between -2 and +1, so I'm not going to use this function. -3 is between -4 and -2, so this is the function I use. Use 2x plus 3 because negative 4 is less than or equal to negative 3 is less than negative 2. So C at negative 3 is 2 times the negative 3 plus 3, which that's a negative 6 plus 3, which equals, goes back to negative 3. Notice I only have used one of these functions to evaluate C at negative 3. I didn't plug negative 3 into x here, and I didn't say that my output was 5. I only used the function where negative 3 fit in the corresponding interval. So, if I said to find C at 0, which function would you use? Would you use function 1, 2, or 3? Well, what interval does 0 fit in? Does 0 fit in interval 1, 2, or 3? You answer the question. Does 0 belong in this interval, or this interval? 1, 2, or 3? Somebody answer the question.
2.
It belongs in interval 2. Negative 2 is less than 0 is less than 1. Since 0 belongs to interval 2, we're going to use x plus 1 quantity squared. So that means C at 0 is going to be 0 plus 1 quantity squared, which is 1 squared, which is 1. So, back to the question. Find C at 2056. Well, again, what interval does 2056 belong to? Interval 1, interval 2, or interval 3?
3.
Why?
Because it's greater than 3.
Because 2056 is greater than 3. So, this is the excuse me. This is the output for any value of x that's in this interval. For any x that's greater than 3, the output is 5. So, the output for C at 2056 is 5. And we're done. That's it. That's the answer. It's 5. So, just expanding this question, three to the 100. That's 3 times 3 times 3 times 3 times 3, 100 times. Now that's a big number, right? It's a huge number. That number, 3 to the 100, does that fit in interval 1? No. It's really big. Does it fit in interval 2? No. It's really big. Is a really big number greater than 3? Yes. So what is C raised to 3? C of 3 to the 100? It is 5. So let me take a moment here to show you what this graph looks like. It's going to be a rough sketch. It's not going to be perfect. So everywhere from negative 4 to negative 2, the function is 2x plus 3. Now we're about to start graphing functions, but I think that y'all should have a pretty good grasp on graphing functions, of linear functions. The 3 means we go up to 3. The 2 means our slope is 2 over 1, so you have to go up 2 over 1, but instead to go to the left, we're going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Alright, and all I'm going to do is I'm going to just graph from -4 to -2. That's that graph right there. I'm not going to continue graphing up this way. We're just going to go, actually I think I messed that up. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. There we go, that looks better. Just that part of the graph right there. Oh, there's a in the function there is a -1 right there. Now we haven't talked about graphing quadratic functions yet, but I can tell you that the graph of this guy is going to go down 1 over 1. It's going to look something like this. And then for everything that's greater than 3, the answer is 5. So it's just going to be a line that looks like this. That goes out in that direction. And that's what this piecewise function looks like. Alright. Any other questions I can address?
Number 20.
Find g of 2, f at 2 minus g of 0. So, just looking at this problem, I already know that I need to know what is function f and what is function g. So I go back up to consider the following functions. F of x is equal to 2x minus 5. G of m is equal to a negative 3m squared minus 1. So, we've already considered function f. We considered function f back in the previous problem 29, where we had the difference quotient involving function f, and we looked at this example of evaluate f at 3, which means plug in 3 into x in f of x. So, similar idea over here. To find f at 2, I'm going to plug 2 into this function f of x. So it's going to be 2 times 2 minus 5, which is going to be equal to 4 minus 5, which is going to equal a negative 1. So we know that f at 2 is negative 1. then we're going to subtract g at 0. Well, now I have to go through and find g at 0. So g at 0 means to plug in 0 for all the m's in g of m. So we're going to have negative 3 times a 0 squared minus 1. 0 squared is 0. Negative 3 times 0 is still going to be 0 minus 1, which is a negative 1. So we have f at 2, which is a negative 1, minus another negative 1. Well, that comes out to be a negative 1 plus 1, which is equal to 0. Does that make sense? Person who asked the question, does that make sense?
Yes, sir.
Do we need to do another difference quotient? I'm sorry, go ahead.
Can we do another one?
Difference quotient?
Yes.
Okay, let's just make one up. So we'll call this like 29. Let's let k of x be equal to, let's pick something different. Alright, let's negative 3x plus 4. Find k at x plus h minus k of x all over h. The difference quotients are always going to be the same format. You're going to have your function evaluated at k plus h minus your function all over h every single time. So we need to do two things. Let's just start off with the main thing. We need to find out what is this. What is k of x plus h? So I'm going to do that in green, since I highlighted it in green. So this means to plug in x plus h in for the x in k of x. So we have negative 3 times, not x, but x plus h plus 4. So do you see, I'm replacing this x with x plus h. Distribute the negative 3. And this, that I'm highlighting in green, is my k at x plus h. So now you just got to fill things in. Going back to the this, we know what k at x plus h is. It's a negative 3x minus 3h plus 4. We're going to subtract all of kx all over h. So, little hint, always put kx in parentheses, because you're about to distribute this negative sign to every single term in kx. So we have now negative 3x minus 3h plus 4 plus 3x plus, minus 4 all over h. Now at this point, terms start canceling out. Terms start canceling out. What do you see that cancels out? What do you see?
Yes.
Come on. The x's? What else?
Positive and negative.
The positive and negative 4. And we're left with the negative 3h over h. Now what cancels out?
The H's.
The h's? And what are we left with?
Negative.
Negative 3. Now, I picked something very much like 29. Go back to 29. Where's 29? Back this way. Where's 29? There's 29. When we did 29, notice what happened. You distributed the negative sign into f of x. Terms canceled out. We are left with 2h over h. The h is canceled out. We are left with just 2. So, I challenge you on your own. This is good practice. If you want to do well on the next exam, practice is key. Practice is key. So, on your own, try something like f of x equal to, make it like 29. So notice what 29 is. You have a variable term, x to the first degree, and a constant. So just make stuff up. 4x plus 7. Or, let f of x be equal to a negative 2x plus 9. Try it out on your own. Try them out on your own. So, I don't know if I have time to go over all of 30. Did y'all get 30? Have y'all done 30 yet?
No.
Alright, it's the same process. It's the exact same process. We want to find the difference quotient for the function g. So the first thing that we need to find is this g at x plus h. That's the first part of the function that we need to find. So g at x plus h literally means to plug in x plus h in for all the m's in g of m. Yes, we can plug in different variables. Even though this is defined as g of m, I could plug in an x if I wanted to. It's just telling me what to plug in. Okay, so we got to evaluate this. Now, make sure that you're following the order of operations while you're doing this. The x plus h quantity squared means to take x plus h and times it by x plus h. Now, I would get used to doing this. In fact, I would almost just memorize this expansion, what this is. Because chances are you're going to encounter this again, and you're going to see this x plus h times x plus h over and over and over. So I would just memorize what the output is. I'll walk you through it. X squared plus xh plus xh plus h squared. That's what you get when you FOIL. And what happens with the two middle terms? They combine together. To give you x squared plus 2xh
Your conference
plus
is
h
scheduled to
squared.
end in 2 minutes.
I would memorize this. Just know it. Now you distribute the -3. And this is the g at x plus h. Now, to shorthand our work here, subtract g of x. So minus the -3m squared is going to be the same as plus 3m squared. Or, since it's g of x, we need to make sure that's an x. Plus 3x squared. Minus a 1 is going to be the same thing as -1 all over h. Again, things start canceling out. We're not going to have time to finish this, but we'll see what cancels out. The 3x squareds cancel out, the 1's cancel out, and we're left with -6xh minus the 3h squared all over h. Then you can cancel out the h's, leaving you with a -6x minus 3h. Alright. We'll see where you're at.
Your conference
on
is now over. Goodbye.
Wednesday. Be prepared to answer questions over assignment 9 as well. I'll see y'all on Wednesday. Email me if you have any questions.